Okay, let's take a look at this one. Lesson 4, question 4. They throw a little bit more at you in this one because they give you the 250 foot and they tell you for 1,000 feet of that gauge wire, it's 4.99 ohms. So essentially they're just throwing another resistor in there is kind of what they're getting at. Kind of voltage drop, but not really fully on with it. But anyways with it. So really to start out with this, we kind of want to work these lamps over here first because we know what the voltage is supposed to be applied at 12 volts. So we can figure out what the resistance is going to be by using R equals E squared over P. So that's going to be 12 squared all over 15. It's going to give us 9.6 ohms for each one of these guys. So first step on this one is just getting to this point right here. This was key to get these. So now essentially we can break these right down into a combination circuit because we know that there's a resistance on both these lines as well. So the next step that we really want to look at is we want to come up with the RT, our resistance total, because we're looking to get our current. Mainly on this one, we're looking to get to the current. And that's how we're actually going to begin to solve it. And once we get to that, we have the key to get every single part of this problem. So to get our RT, it's just the lamps plus the wire. So we're going to do the fictional resistor thing. I'll use a different color. We'll use the fictional resistor. And we'll just leave that for now. So that fictional resistor of the lamps, it'd be 1 over 9.6, 1 over plus 1 over 9.6 plus 1 over 9.6. Use the reciprocal formula. Let's punch in those numbers and do that right now. Gives us 3.2 ohms. So this resistor is 3.2 ohms. So once we're to this point, we already know by 1,000 feet is going to give us 4.99 ohms on this wire. So we're at 500 because it goes out and comes back. So it's going to be half of that. So we're looking at about 2.495, I believe is right. And they actually had to round this rate up to 2.5. So that's what we're going to do here too. It's pretty close. Won't throw the numbers off too much, but I would recommend on problems like this, keeping it on the calculator is not a bad idea. So 2.5 plus 3.2. 5.69. So our RT is 5.69. 5. Pretty straightforward, but the next part that we want to solve for is our current. So the current on this is going to be I over E. I equals E over R. Pretty straightforward. We know it's 12 divided by 5.695. And that's going to leave our current at 2.107. And change, obviously, there's quite a few numbers after that. So that leaves us at this point right here where we have our current, we know our resistance, and I believe, yes, they're asking for the wattage, and they want to know the wattage on, well, pretty much how much power are we delivering to each lamp. Well, we have the current now. We have current, and we know resistance of the wire. So the next step is our power formula. P equals E squared at the lamps over R. But we have to remember also, the part that's going to be a bit tricky is there's a voltage drop on this. There's a voltage drop getting onto this. So there's another fictional resistor here, which is why we solve for current. So we know that this is 2.495. So we know that. We take our current number, this, because we want to know the E there. We want to know how much power is dropping there. We don't need to. We could actually just do it for this one too. Because current's constant in a series circuit. That's the trick here with this one, is we simplified it down to just a simple series circuit with a couple of resistors. So we're going to take our current and times that by our resistance. So we know that we're applying 6.752 volts to each one of these. So we know how much voltage is applied to each one. So now we can actually take those numbers and actually punch it in to find out how much power we're actually delivering. So it's P equals E squared, which is why we had to get this number, over R. So we'll take that number, square it, and divide it by our resistance. So each one of these is actually going to see 4.748 watts for each one of these. So basically, in a nutshell, there's two resistors, is basically what they're doing. Is the distance of this wire, you're going to have a resistance, there's going to be a voltage drop here. So these aren't actually going to see 12 volts. That's why the numbers seem a little bit funny. But once you get this, you break it down to this point, then you know how much voltage is applied, and you know that's a good number. You can use that to solve for anything they ask you out there. This is kind of a tough question, but it is a good solid question, and they do repeat these questions like this one. I've seen this on a test before, pretty similar to this exact question. But it is a good one.